In today's video, we're going to connect tables and equations. Evidence-wise, we're going to analyze the relationship between variables using tables. We're going to write equations to represent the relationships between variables. We're going to analyze and identify patterns in tables to make sense of various problems. That basically just means that we're going to make equations from them. Learning experience, we've actually got 2 examples and 2 you-dos, so it'll be a little bit of a longer video this time. We'll have our things to remember, and then there are like 4 suggested practice problems at the end. So let's start off by making a table from this equation, y is equal to x plus 8. We're going to start with this, and we're going to fill in this table. Now, what's cool about making a table from an equation is we get to choose the values for our independent variable. You remember from our last video, if you don't, go watch it, that x is almost always the independent variable when you are given some sort of equation. Likewise, when you have a table, this first column, the left-hand side, or sometimes if you have a table that goes horizontally, rather, it'll be the top row. That should be your independent variable. You get to choose what they are. In this case, I've already chosen just 1 through 5 to make things simple. And we're going to go from there. So all we need to do to create a table from our equation is rewrite our equation, but instead of using the variable x, we're going to pick one of our values. So let's pick 1. We're going to substitute 1 in for that variable, and then we're going to solve our equation. So we have y is equal to 1 plus 8. 1 plus 8 is 9. So if x is 1, y has to equal 9, and we can list that over here in our table. If we do it for the next value, we'll pick 2, and we'll repeat the process. So y is equal to 2, this time, plus 8. When we do that, we get y is equal to 2 plus 8 is 10. So in our table, we can list that 2 would be equal to 10. We can, of course, repeat that for each of these. And if, and this won't always work, but if your independent variables have a certain pattern, you should start seeing a pattern in your dependent variables here as well. And sometimes that can be useful, because rather than going through and doing all of them, like I seem to be doing right now, you can actually just use that pattern to help you predict the other values in your dependent column. So for example, I think it's a reasonable guess to say that that's going to be 13. And that's all you gotta do. When you have an equation, you just need to substitute in the values for your independent variable and see what you get. In this case, we got 9, 10, 11, 12, and 13 for x's 1, 2, 3, 4, and 5. Sometimes that pattern is not going to be there. Sometimes the x values are going to be in different orders. Usually you get to choose. Sometimes the problem gives you values that you have to pick. It just depends on the problem. So take a moment to pause and write this down if you need to, and then we're going to start our first you-do problem. So, first you-do problem. We're going to give it some real-life application by making it into a word problem, although I promise you it's not that bad. So, James wants to buy some cheese.
Cheese.
A pound of cheese.
Cheese.
Costs $3. The equation D is equal to 3C, where D stands for the amount that James will pay, and C stands for the amount of cheese he buys. You're going to complete this table using the equation D is equal to 3C. You can see our table there. You're going to fill it in. We've already picked our values for our independent variable, which is, of course, C. So pause the video now, give this a shot, fill in the rest of the table, find the values for D. So now that you've completed that first you-do, let's look at a different example. This time, we're starting with the table and we want to make an equation. Specifically, we have James again, who finds a table to help him buy cheese.
Cheese.
We're going to write an equation to help us model this situation. So it's a little bit trickier, although if you notice the table is the same as in the you do problem. But we're going to try to find a pattern. And some people are very tempted to look for a pattern going this direction. We do not want to do that. We want to look for a pattern that goes across, in this case. We want to connect our independent variable to our dependent variable. So if we look at c is equal to 0, we see that d is also equal to 0. So that doesn't really tell us anything, but we know that if we have 0 and we end up with a 0, usually the way that ends up happening is by multiplying something by 0. So it's fair to bet that we're going to multiply something. We could also already, since we know that our dependent variable is going to be d, we could at least do d is equal to. It's a good start to our equation, though we're obviously not done. So next, we have 1, and somehow that becomes a 3. So there are two things that we could try here. We could try adding 2, or we could try multiplying it by 3. We don't know, but at least we know that it's probably one of those two. So let's look at the next set of values. We have 2, and it becomes a 6. So let's try both of these. Is 2 plus 2 equal to 6? No. 2 plus 2 is, of course, equal to 4. So it's not going to be that first idea of just adding 2. Instead, let's try multiplying 2 by 6 and see if we get 6. Multiplying 2 by 3, rather, and getting 6. So we have 2 times 3 is equal to 6. Well, 2 times 3 is 6, and 6 does equal 6. So it seems likely that we're going to multiply this by 3. Let's test it with one more just to make sure. Is 4 times 3 equal to 12? Yes, 12 is definitely equal to 12. So what we're going to be doing is we're taking whatever value we have for c, and we're multiplying it by 3. So our equation then is d is equal to 3 times c. And that's all we gotta do. Now this one does take a little bit longer to do because you have to look at your pattern, you have to look at your values, you have to find that pattern and make it into an equation. But with the kind of patterns that we're looking at so far, pretty simple. You're either adding or multiplying or dividing or subtracting some number from your independent variable to get your dependent variable. We're not going to throw anything at you yet where you have to do two different things, and that'll get a little bit trickier. Pause the video again if you need to. That way you can get this copied down. And then we're going to move on to our second you-do. So in our second you-do, you have Wallace who sells cheese.
That's it, cheese.
He creates this table that you see there to help him sell the cheese.
Cheese.
You're going to help him make an equation based on the table. So the same idea as in the previous example, but this time you have a different table, you've got different values. Look for the patterns, help you make an equation. Pause the video, give this a try. Alright, so you should be just about done writing things down. This is never a bad thing to write down, though. Things to remember. When going from an equation to a table, you're going to pick a value for the independent variable and calculate your dependent variable. You're going to store those in your table. If you're going the other direction, you're going from a table to an equation, you're going to look for a pattern in that table that connects the two variables. Then you're going to use that pattern to make an equation. Finally, cheese.
Cheese.
Our suggested practice problems for today are from Savas. There are two problems where you're creating an equation from a table. There aren't any word problems associated with it. It's just look at the table, make a pattern, see what you can come up with. And then in 5 and 6, you're going to use the equation to fill out the table. So just the reverse. Give these a shot, write them down. If you need to rewind and rewatch any of the examples, do so. Remember, those are there so that you can write down the examples so that you have them in your notes. And yeah, good luck.
Cheese.